Hi, this is Rick Graziani, and I want to talk a little bit about understanding layer 2 and layer 3 addresses, Ethernet, MAC address tables, and ARP, putting it all together a little bit for you. So why does a device have an IP address? Well, so it can communicate not only with devices on its own network, but on other networks as well. On an IPv4 and IPv6 address, it contains a portion of the address which describes which network that the device is located on. So that way routers can use that information to forward packets to the correct network. Kind of like a zip code that you use in addressing information. Instead of just putting somebody's name on the envelope, we need addressing information like, well, city, state, zip code to get the information to that specific location. So why does the device have a MAC address then? Well, remember that Ethernet is a layer 2 data link technology, which is for NIC card to NIC card communications on a multi-access network. What I mean by that is that there might be more than one device on that network. It's like having multiple people in the same room. Who are you sending this message to? It's not just two people where you can just say, hey, you, and you know the other person's talking to them. You know the other person knows that you're talking to them specifically, but there might be 5, 10, 20 people in the room. And if I say, hi, I owe you $20, well, who am I talking to? So the MAC address is used to get the packet physically from one NIC card to another NIC card on the same network. Okay, the alternative would be to send all messages to all NIC cards. Okay, and remember, by the way, when the router receives that, if the packet is for another network, the device like A here will send that packet to the router's NIC card to NIC card communications. The router will remove that Ethernet header, look up the destination IP address in its routing table, then encapsulate it in the proper data link header trailer for that interface and send it out that interface onto the next hop network or next hop device. Okay. But anyway, let's focus on this right now. What devices have an IPv4 ARP table and why? Well, any device with an IPv4 address and an Ethernet MAC address is going to need an IPv4 ARP table. It's going to need that to resolve what IP address it needs to send the packet to and the destination MAC address so it can send it from its own NIC card to that NIC card. Okay, so generally this is when the IPv4 address is known, but we need to get the packet physically to the device. We need to know its MAC address. Okay, again, this is all NIC card to NIC card communications on the same network. Here's a little analogy. Let's say I have an IP packet that I want to deliver to Prescott. It's his exam. He got an A+ on it. Okay, so I'm looking out there in the room, and I know that Prescott's in the room someplace. So I'm going to send what's equivalent to an ARP request. I'm going to say, hey, everybody out there, this is Rick. Prescott, I know you're in the room, but where are you? So everybody's going to hear that message. And everybody's going to go, I'm not Prescott, except Prescott. Prescott will go, well, wait a minute, this is for me. So Prescott will respond with, hi, Rick, this is Prescott. I'm right over here. So now I can physically determine where Prescott is and deliver that IP packet, that exam to him directly. Okay, so ARP, that's an ARP. We're going to talk about ARP tables and MAC address tables more in a moment here, but let's also take a look at what devices here would have an ARP table. Just kind of getting ahead of myself here. I was just going to talk about MAC address tables, but I'm not done with ARP tables. So what devices have an IPv4 ARP table? I said, again, devices with an IPv4 address and an Ethernet MAC address. So that would be A, PCB, PCC, and yes, the router. The router would actually keep separate ARP tables for each of its Ethernet interfaces. Okay, so devices will populate their ARP tables by sending an ARP request and receiving an ARP reply. This is all going to be explained in just a moment. Also, if they're the target of the ARP request, so they're the ones that are going to be sending back the ARP reply, we'll see how they'll be populating their ARP table as well. This will all become clear in just a moment. So what table does a switch have and why? So we're taking a look at these PCs or end devices and their ARP tables. What about a switch? Well, a switch is going to have a MAC address table. MAC address table is so it can learn what ports have which MAC addresses so it can try and forward those frames directly out that port. Okay, so by the way, before I move on to the MAC address table, I just want to mention that people ask me, well, do switches have an ARP table? They might. If the switch has been assigned an IPv4 address, why would a switch be assigned an IPv4 address? It's so you can manage that switch remotely. So a network administrator sitting here at PCB can remotely log into this switch and manage it. Then the switch is acting like another device on the network, another computer on the network. It's going to have an IPv4 address and a MAC address. And in that case, it would have a ARP table, okay? But we're gonna keep this simple. So we're just gonna have our end devices have the ARP tables and our switches will have the MAC address tables. I mentioned MAC address tables are for learning about where the destination MAC addresses are. We'll see how it does that in a moment by examining the source MAC addresses and forwarding the frames when it can just out a single port. Okay, switches do two things, learn and forward, learn and forward. With every frame that comes in, learn and forward, learn and forward. Okay, that's just, they're very simple. That's all they're going to be doing here. So switches are going to learn by examining the source MAC address and the incoming port. If that information is in its MAC address table. If it's not, it will add the source MAC address and the incoming port number to the table. And it keeps it in there for 5 minutes, typically. If it's already in the MAC address table, it will reset the 5-minute timer. It says, I'll keep it in there another 5 minutes. Then it's going to try and forward the frame. It does that by examining the destination MAC address in the Ethernet frame. For unicast destination MAC addresses, it says, is this in the MAC address table? If it's not, it forwards it out all ports except the incoming port. We call that an unknown unicast. If it is in the table, then we'll forward out just that port because it had previously learned it by examining a source MAC address. We'll see how this works. If it's a broadcast or a multicast, I'm not going to talk about IGMP here. We'll just say that it will forward it out all ports except the incoming port. All right, let's bring all of this together. Okay, if you're still unclear about everything, this should bring it together for you. Okay, so we have the switches here have, switch 1 and switch 2 have the MAC address tables. Okay, PCA is going to send a packet to PCB. Okay, so there's the source IPv4 address, destination IPv4 address in the packet. It's going to encapsulate this in an Ethernet header. Okay, so it knows its own source MAC address, 0A. But what it needs to know is the destination MAC address. Well, the first thing that PCA needs to determine is am I, 192.168.1.10, am I on the same network as this destination IPv4 address? And the way it determines that is it takes its own source IPv4 address, does an AND operation on its own subnet mask, and determines what network it belongs to. Then it takes the destination IPv4 address, not knowing the destination's subnet mask. It says, well, look, if you're on my network, we have the same subnet mask. So it'll take the destination IPv4 address, use its own subnet mask, do a bitwise AND operation, and determine the network that it might belong to. If it matches, if that AND, the result of that AND operation matches its own network, its own calculation from its own source IPv4 address and subnet mask bitwise calculation, if those two network calculations match, it will say, hey, we're on the same network. I can send this packet directly to you. I don't need to send it to the router. So in this case, that determination is that they're both on the same 192.168.1.0 network. Okay, so therefore PCA needs the MAC address associated with the destination IPv4 address. We don't need a router in this case. So where is it going to look for that information? Okay. Well, it says I need the destination MAC address, excuse me, associated with 192.168.1.20, the destination IPv4 address. It's going to look for that in its ARP table. Excuse me. In this case, it's not there. So it's going to put the packet on hold and send out what's known as an ARP request. Okay, in this ARP request, it says, let me back up here. It says, I know, this is the address I know, 192.168.1.20. I need the MAC address associated with this IP address. Okay, so it's going to encapsulate it in an Ethernet frame with its own source MAC address, and it's going to use a broadcast as the destination MAC address. Everybody on the network, every NIC card on this network needs to process this ARP request. It's a broadcast. Okay, and that's going to be sent out of the NIC card. Now, I'm going to mention this more in a moment, but A is also going to include in this ARP request its own IPv4 address and its own MAC address. Why? So the receiver of the ARP request, whoever needs to send back the ARP reply, has that information so they can send the ARP reply directly back to PCA. We'll see that in a moment. Okay, so the ARP request I mentioned contains the sender's layer 2 MAC address and layer 3 IPv4 address. Okay, it is sent out PCA, it's NIC card, and here it comes into the switch. Switch is going to do two things: learn, forward, learn, forward, learn, forward, every Ethernet frame that comes in. So has it learned anything here? Okay, it examines the source MAC address. So we're looking at the ARP request here. Remember, the packet is on hold. Examines the ARP request, the source MAC address, and says, hey, I just learned that on my port 1 is 000A. There's the learning. Next, it's going to do the forwarding, examines the destination MAC address. Says, oh, wait a minute, this is a broadcast. That's not going to be in my MAC address table. Instead, I'm going to forward that out all ports but the incoming port. Okay, let's take this down to switch 2. Switch 2 receives this ARP request with this Ethernet frame. It really doesn't care that it's an ARP request. It just cares about the source MAC address, destination MAC address. Learn and forward, learn and forward. So switch 2 receives this information. It says, have I learned anything? And it has. It says, I have just learned that on my port 2, okay, my port 2 is 000A. So it's going to add that, the incoming port number 2, and the source MAC address 000A to its MAC address table. Here's a common misconception or mistake that some students might make. They'll think that they put in this switch S2's MAC address table, it puts the information of the incoming port number of switch 1, which would be port 1. No, it has no idea what switch 1 is doing here. It looks at it. Remember, these devices live in a bubble, okay? So it has no idea what's in other switches' MAC address table. It's only concerned about its own MAC address table. The incoming port number the frame came in on was port 2, source MAC address 000A. Okay, then it wants to forward the frame, so it looks at the destination MAC address. It says, oh, it's a broadcast, so I'm going to forward it out all ports. Okay, so next what happens is every device is going to, the NIC card has to process the ARP request because it's a broadcast. So it says, okay, I need to process this, send it up to my ARP process in my operating system, examine this, we call this the target IPv4 address, 192.168.1.20. That's what A is looking for. It says they have to examine, see, is that me? C sees it and says, no, that's not me. I'm not that IPv4 address, so I can ignore this ARP request. I don't have to send an ARP reply. The router also receives it on its on this NIC card here, on its port 1, and examines the target IPv4 address with its own IPv4 address and goes, no, that's not me. Now, routers will not forward broadcasts, right? So it will not go out this other port. PCB gets it and says, am I the target? And voila, yes, it is. It is the target 192.168.1.20. So it's going to say, oh, somebody's looking for my MAC address. I'm the target of this ARP request. Now, one of the things we mentioned is in this ARP request contains the sender's layer 2, its MAC address, PCA's MAC address, and PCA's IPv4 address. Okay. So A is going to take that information, put it in its own ARP table, because it's going to use that for the ARP reply going back. Okay, so let's do the ARP reply now. Okay, PCB is now going to put together an ARP reply. It says, this is what you were looking for. Okay, so this is known as the sender's IPv4 address and the sender's MAC address. This is what you were looking for. You knew my IPv4 address, but this is what you want, 000B. I'm sending this from my MAC address, the Ethernet frame. So here's the ARP reply message. Now here's the Ethernet header. And the destination is going to be to 000A. I got that information from the ARP reply. I'm going to send this directly to you. There's no reason why all these other devices need to copy in this information. By the way, I just want to mention that. Why don't devices copy in the initial ARP request information? Why didn't C and the router copy in that information? It's really not necessary because most devices aren't talking to all other devices on the same network. You're usually talking to things like maybe the printer, the router, you might have a server on your network, but in most cases, you're sending everything just to the default gateway. So it's not important that these devices know everybody else's MAC addresses. It's kind of a waste of memory. And populates these ARP tables with unnecessary information. Okay, that was my alarm. All right, let's continue with this ARP reply coming from B. So saying, you knew my IPv4 address. This is what you wanted, 00, my MAC address. And I'm going to send it directly to you. So that's going to come in a port 3 into the switch. What do switches do? Learn, forward, learn, forward, learn, forward. That's all they do. Okay, how do they learn? By examining the source MAC address. Has it learned anything here? Let's see. Coming in on port 3 is the source MAC address 000B. Yep, it has learned, so it adds that to the table. Forward, it's going to examine the destination MAC address 000A. Is that in its table? It is. It says, oh, 000A, that's in my table. I only have to send this frame out port 1. I learned that previously by examining a source MAC address of a frame coming in to port 1. So I know to send that out just to port 1. Okay. All right. So A receives this, the ARP reply, and says, oh, I've been waiting for you. Not too long, happens pretty quick, a lot quicker than me talking about it. Thank goodness. And says, this is what I've been waiting for. I knew the IPv4 address. I've been wanting the MAC address associated with it. Okay. This is the sender of the ARP replies IPv4 address and MAC address. Okay, so here it comes into the into PCA. And I also want to just mention the ARP reply also contains the what we call the target, who this ARP reply is for, the IPv4 address of A and its MAC address in the ARP reply. But what's important here, or the point I'm trying to make here, is it also, of course, contains the sender's MAC address and IPv4 address. This is what PCA was waiting for. Okay, so A adds that information to its ARP table. Okay. Now it knows to reach 192.168.1.20, it needs to send it to this NIC card 000B. All right, so it can now take this packet off hold, put the destination MAC address 000B, and it can send that out of its NIC card. Let's continue this process. It's not quite there at B, right? It's just now going out the NIC card. Okay, it goes out the NIC card of A. It comes into switch port 1. Okay, has the switch learned anything? Learn forward, learn forward. Learn source MAC address, port 1. It already has that information. So it just resets to 5-minute timer. Forward, destination MAC address 000B. There it's in its MAC address table already too. So it says I can just send that out port 3. So both those pieces of information are already in the table. Okay. It had populated, the table was populated by the ARP request and ARP reply. Okay, so now it can just forward that Ethernet frame out to port 3 directly to PCB. Okay, so that kind of brings everything together with layer 2, layer 3, Ethernet, MAC address tables, and ARP. All right, so hope that helped. And more to follow. Thanks for listening.